Solve the following quadratic modeling problems, algebraically or graphically, where appropriate. Round out answers to the nearest hundredth, unless otherwise stated. And by the way, hundredth is 2 decimal spaces. Use appropriate units for all solutions. So the graph at the right describes the height of a bridge that stretches across a body of water. And use the graph to answer each question below. Well, what is the maximum height of the bridge? And we can see it here. Looking at our graph, it looks like it is 10 feet. Simply looking, height of the bridge is this point right there. How long is the bridge? Well, how long the bridge is at this value right here, which is 20 feet. And lastly, state the interval over which the bridge is sloping upward. So it's going to be between two values. And we're going to start at the beginning, and we're going to go up, 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 all the way up to our blue point right there. And what that is it's going to be between 0 and the x value of that blue point, which happens to be 10. Number 2, the equation y equals negative 0.06x squared plus 0.96x models the height of the winning long jump at a middle school track meet, where x is the horizontal distance in feet from the beginning of the jump. Use your calculator to answer all parts of the question. The key to the calculator is, can we get it so we can see the whole picture on our screen? So we're going to go to y equals, and we're going to type in the function, which is negative 0.06x squared plus 0.96x hit graph. And luckily enough, we can at least see something on this graph. And we're going to go to the window now. I'm going to change it. I'm going to leave this -2 just so we can see our axis for our x minimum. If you prefer to use 0, put 0. But we need more values for the x max. So I'm going to try 20 instead of 10. And I'm going to change down here the y min to be -2. But we could see everything that we needed to see. But really what we want is we want a better picture, a more thorough picture here. And now we can see everything. We can see where the graph starts. We can see where the graph finishes. We can see how tall the graph is, so to speak. And now that we know that, then we can use our calculator to answer all parts of this question. The first question being, what is the height of the winning jump? Well, to figure out the height of the winning jump, we're going to go to second, and trace, and maximum. And we're going to go a little bit to the left of what we think the highest point on this graph is. Somewhere there. Your numbers at the bottom of the screen don't have to be the same as mine. Enter. And then we'll go a little bit to the right. Enter. And somewhere in between those two, we can hit enter. And the question is, as I go back and look at the problem, what is the length of the winning jump? And sorry, I must have read the wrong one, because what we were just finding is, what is the jumper's maximum height? So our jumper's maximum height is going to come from the y value of 3.84 feet. I accidentally did that one first, so I'm going to put a B by this graph if you're watching the video so that you know. But really what we wanted to know, first of all, is what is the length of the winning jump? So the value that we're looking at here on our screen, to find the winning jump, we want that point right there. So we're going to go back to our screen, and we're going to press second, trace, and this time we're going to do the 0 function. And we're going to go a little bit to the left. Again, your numbers at the bottom of the screen don't have to be the same as mine. Enter. And then enter. And then enter. And there is our first answer, which is going to be the 16 feet. In this particular case, at least on that first one, you might be able just to look at your table or look at the actual grid. But it doesn't always work out to be a nice even number like that. So you're probably better off using the second trace and the 0 feature for that one.